Hey guys, welcome back to the channel. Today we have a special video on the OSI model, but it's gonna be a simplified version of the OSI model. So as you can see on the screen, the OSI model is the Open Systems Interconnection model. Okay, let's go to the next. All right, so the Open Connection Reference Model or OSI stack describes 7 layers that computer system use to communicate over network. It was the first standard model for network communications adopted by all major computer and telecommunication companies in the early 1980s. All right. All right. So we have 7 layers on the OSI model. We have application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. But the way we will describe the layers today, we will start with the first layer, which is the physical layer. So we'll start from the bottom and all the way to the top. All right. So let's switch to the physical layer. All right, the physical layer is concerned with the following: how bits are represented on the medium, wiring standards for connectors and jacks, physical topology, synchronization bits, bandwidth usage, multiplexing strategy, and also a transmission of bit on the network along with the physical and electrical characteristic of the network. So when you see physical layer, think about bits. Okay, so next. All right, so as you can see on the screen, we have the signal, which is you can see the copper cable, which is an electrical signal. We have a fiber patch cable on the screen, and media is light and also air. So when we have all of this, we talk about physical layer. All right, so data on the computer network is represented as a binary expression: electrical voltage on copper wiring, or light carrying via fiber optic cabling can be represented as ones and zeros. Network media type describes several standards for network connection. For example, the TIA/AIE 568B standard describe how to wire in RJ45 connector for use on the 100 base TX Ethernet network. So again, when we talk about physical layer, we see bits. And if in your exam they ask you about copper, electrical, RJ45, or fiber optic, and even the Wi-Fi, think about it. We are on the physical layer. All right. All right. So layer 2. The data link layer is concerned with the following: packaging data into frames and transmitting those frames on the network, ensuring that frames do not exceed the maximum transmission unit, MTU, performing error detection, correction, uniquely finding network devices with addresses, handling flow control. So now when we see data link layer, think about frames. All right. All right, data link layer. In fact, the data link layer distinct from the other layers in that it has 2 sublayers, MAC and LLC. Let me remove this. All right, so the MAC is media access control, is physical addressing, logical topology, method of transmission on the media, and LLC connection services and synchronization transmission. So when we have media access control in LLC, we are on the data link layer. All right, network layer number 3, layer 3. The network layer is primarily concerned with forwarding data based on logical addresses. All right, logical addressing, route discovery and selection, connection services, bandwidth usage, multiplexing strategy. All right, examples of devices found on the network layer includes router and multi-layer switches. The most common layer 3 protocol in use and the protocol on which the internet is based is IPv4. However, IPv6 is beginning to be more common on network today. So now, guys, when we are on network layer, we see packets. All right. Now, for transport layer, the transport layer acts as a dividing line between the upper layers and lower layers of the OSI model. Two common transport layer protocols are TCP and UDP. All right. Transmission Control Protocol (TCP) is a connection-oriented transmission protocol. User Datagram Protocol, which is UDP, is a connectionless transport protocol. The transport layer is concerned with the following: TCP/UDP, windowing, buffering. In addition, the TCP and UDP Internet Control Message Protocol (ICMP) is another transport layer protocol you are likely to meet. ICMP is used by utilities such as ping and trace route. So transport layer is segments. Okay, now we're on session layer. The session layer is concerned with the following: setting up a session, maintaining a session, tearing down a session. The session layer is responsible for setting up, maintaining, and tearing down session. You can think of a session as a conversion as that needs to be treated separately from other sessions to avoid the intermingling of data from different conversations. All right, so we're still on layer 5, which is the session layer. Now let's just go over the 3 points that we saw in the session layer previously. Okay, setting up a session. Setting up a session is checking user credentials, for example, username and password. Assigning numbers to a session's communication flows to uniquely find each one. Negotiating services needed during the session. Negotiating which device begins sending data. Now, maintaining a session. Transferring data, reestablishing a disconnected session, acknowledging receipt of data, tearing down a session. A session can be disconnected based on agreement of the devices in the session. Alternatively, a session might be torn down because one party disconnects or because of an error condition. Yes, we're still in layer 5, session layer. Okay, so session initiation protocol SIP is an example of a session layer protocol which can help set up, support, and tear down a voice or video connection. NetBIOS is an application programming interface API developed in the early 1980s to enable computer communication on a small local area network, specifically a PC network, which was IBM's LAN technology at the time. All right, so now we are on layer 6, presentation layer. Okay, the presentation layer is concerned with the following: data formatting, encryption. The presentation layer formats the data being exchanged and secures that data with encryption. Data formatting, as an example of how the presentation layer handles data formatting, consider how text is formatted. Some applications might format text using American Standard Code for Information Interchange ASCII, while other applications might format text using Extended Binary Code Decimal Interchange Code EBCDIC. All right, now encryption. Imagine that you are sending sensitive information over a network, credit card number or bank password. If a malicious user were to intercept your transmission, they might be able to obtain this sensitive information to add a layer of security for such transmission. Encryption can be used to scramble encrypt the data in such way that if the data were intercepted, a third party would not be able to unscramble or decrypt it. However, the intended recipient would be able to decrypt the transmission. All right, so now we are on application layer, the last one. The application layer is concerned with the following: application services, service advertisement. Okay, the application layer gives application services to a network. An important concept is that end users, applications such as Microsoft Word, live in the application layer. Instead, the application layer supports services used by end user application. For example, email is an application layer service that does exist at the application layer, whereas Microsoft Outlook, an example of email client, is an end user application that does not live at the application layer. Another function of the application layer is advertising available services. All right, so now you can see on the screen the network application. We have Google Chrome, Microsoft Edge, Firefox, and Microsoft Word. They are network application managed by the application layer. All right, we have also application services. Example of the application services living at the application layer include file sharing and email. Service advertisement. Some applications services, for example, some network printers periodically send out advertisement, making their availability known to other devices on the network. Other services, however, register themselves and their services with centralized directory, for example, Microsoft Active Directory, which can be queried by other network devices seeking such services. All right, now TCP/IP stack. The ISO developed the ISO references model to be generic in terms of what protocols and technologies could be categorized by the model. However, most of the traffic on the network and traffic on corporate networks is based on the TCP/IP protocol suite. Therefore, a more relevant model for many network design and administrators to reference is a mode developed by the U.S. Department of Defense. This model is known as the DoD model or the TCP stack. All right, guys, thanks for watching my simplified version of the OSI model. I hope you guys enjoyed, and I also hope it helps you understand the different layers on the OSI model. Guys, if you have any comment, please feel free to leave it in the comment section below the video. And guys, don't forget to click on the subscribe button and also click on the bell for notification so you will never miss any of my videos.